So welcome to track one, panel one, emerging architectures for modern data infrastructures. My name is Henning Kuich and I'm a scientist at Bayer. I've been asked to moderate this panel today. And what we want to exchange on is that it seems that nowadays the primary business value of systems is derived from the analysis of their data rather than the actual software, which means that the fastest growing companies are the ones that use these systems to enable data-driven decision-making and create data-powered products. So we want to talk about how to build enabling data architectures and which sorts of systems are in the lead here. And I'm joined by our panelists today, Philip Carnelley from IDC, Daniel Howard from Bloor Research, and David Richards from Wendisco. So first of all, it's very nice to meet you guys face to face since we've only been chatting through email. Would you guys maybe like to take a quick couple of sentences each to introduce yourselves and say hello to everyone? Maybe Philip could start.
Okay, sure. Yeah. Hi, everyone, and nice to be here with you. I'm Philip Carnelley, and I'm an industry analyst and consultant based in London, working in the areas of big data and analytics for IDC, which is an international technology advisory firm.
Sounds good. Maybe Daniel could continue.
Sure. Hi, everyone. I'm Daniel Howard. I'm an industry analyst as well. I'm at a different firm, Bloor Research. And I specialize in information management, DevOps, and testing primarily.
Which is David.
And I'm David Richards. I'm the co-founder and CEO of Wendisco, a Silicon Valley, UK tech company focused on hyperscale infrastructure, big data, cloud, etc.
Sounds good. So I guess since we only have 15 minutes, let's dive right in. And maybe we sort of keep the sequence here that we had with Philip, Daniel, and then David. So just to get started, which architectures do you guys see your customers develop? And what, if any, role do the knowledge graphs at this point play in them? Maybe Philip could start.
Sure. Well, what I'm seeing, particularly the bigger organizations, is they're moving to a kind of hybrid architecture. Perhaps a look back in history, really. As I say, I operate mainly in the area of business analytics and applied analytics, and the kind of things that you do with knowledge graphs is part of that. And once upon a time, everything was very sort of straightforward and simple, and everybody just ran analytics on numeric databases, really, in a data warehouse. And that was very restrictive, really, and high maintenance. So the next sort of stage in the evolution of the industry, really, was to put everything in a data lake. And so we moved to this open source based thing where, Hadoop played a large part, and Apache Spark, those kinds of technologies. But that had its own kind of problems, I think, because people were just dumping everything they could in the data lake, and getting things out and understanding what you got in there and analyzing it became quite an issue. So now I think people are moving to more of a tiered architecture where they use storage like Amazon S3 or something like that, but then they have an intermediate layer, what you might call the storage plane, which is a number of repositories, if you will. And then on top of that, there's a kind of access layer, which sort of understands the semantics. Then finally, on top of that, you have your analysis tools. And in there, particularly the repositories, you might have a number of different types of storage, like a knowledge graph, or you might have a sort of relational model, something like Snowflake, perhaps if it was in the cloud. So, we're seeing this evolution, and it becomes much more kind of use case oriented. So you have something that can handle different types of workloads. Now that brings its own issues, how you get the data in and out, where you keep it all the time, things like that. But that's kind of where people are going, is to this sort of multi-purpose architecture. It's more structured than a data lake, but not as restrictive as what we had 10, 20 years ago. Maybe I'll stop there. Let somebody else have some input.
Sure, I guess it's my turn next. So I broadly agree with what you just said, Phil. One of the things I've noticed a lot of, which I find interesting, is a sort of cross-pollination of graph technologies. So, you brought up this issue of data lakes and becoming, data swamps. I believe was the term a few years ago. One of the things I've noticed is I work with in sort of the data governance space. And one of the things which is becoming increasingly common there is leveraging knowledge graphs as sort of a backbone for a data catalog. So I think that, this paradigm, which is not necessarily becoming sort of commonplace, but certainly becoming increasingly in vogue and available to organizations, is this idea of not necessarily managing a graph themselves, but buying into products which will, do it for them and have, not sort of a comprehensive graph database, but will model the data they have inside their own graph and then expose it to them in a form they can understand. And I have a few more examples, but I think I'll probably save those to later in the presentation, hopefully.
So I agree with what you guys have just been saying. I think if you take a step back, I think in general, Philip, you mentioned the world started to, the idea of big data came into fruition around 2010, 2011, with Hadoop primarily batch-based, map-produced processing, largely done on premise. And that's where WANdisco was initially focused, providing disaster recovery solutions. Where EMC had left off is where we were starting. And then we realized 2013, 2014, that actually this was not going to happen on premises at all. So I originally thought that maybe this was going to be more hybrid, but actually hyperscale, hyper-converged infrastructure, artificial intelligence, the convergence of analytics, artificial intelligence, machine learning is only going to happen in the cloud. And there are winners and losers definitely from this, but when the CIO of one of the largest retailers told me a few years ago that they had use cases that required 3,000 CPUs now and X thousand CPUs in the future, that these are not good use cases for him to buy on premises that level of CPU power required to run machine learning algorithms that they were building. So the technologies that are now being deployed by companies, and I was looking at a telecommunications company a couple of weeks ago, they are throwing away the Verticas, the traditional data warehousing technologies. Nobody's going to run Hadoop in the cloud, right? They can't. It's not appropriate for real-time analytics. So the technologies that we're now using in the world, people aren't going to run Oracle in the cloud, right? They're going to use a knowledge graph. They're going to use a different type of data and analytics. Tooling is fundamentally required. So I think we're seeing we're sort of in the second innings, I suppose. We think there are still about 300 exabytes of data that live on premises that still have to move to the cloud, and that's the compounding effect of that is growing all the time. So I fundamentally believe that this has to happen in the cloud, and it is actively happening in the cloud, and the technologies used in the cloud are fundamentally different to those used on premises.
That makes sense. So a lot of agreement on at least the grand scope. Maybe something to dig into a little bit more specifically. What are maybe some examples of concrete problems that are being addressed with knowledge graph specifically? So Dan, you sort of mentioned that you might want to go into that a little bit later in more detail, but maybe you can.
I think in the context of this, of the time we have, this is definitely counted later. So. There's another product which I'm familiar with. So I mentioned before, one of my key interests is testing, and I was speaking to a testing vendor a few months ago who was essentially using a graph backend for their product to model their test automation system. And again, I think this is, it's only obviously one vendor, but I think it's a really good example of, because it's not at all the kind of thing you'd expect when someone says knowledge graph, a graph use case. It's kind of out there, but it's obviously working very well for them because it allows them to, if you think about what a system and a test really is, you've got a lot of interlocking parts, a lot of things which affect each other, a lot of integrations and interoperations. So if you think about actually having a graph of that, it's a really good idea. And they've been able to really, really enhance the way they model environments. And that's been really beneficial for them. So as I said, I don't think it's an obvious use case, but I think that makes it all the more valuable because it demonstrates just how widely applicable the graph technology can be.
I could say that the couple of use cases that I see most often based on knowledge graphs are the ones around fraud and risk, firstly, sort of where people in financial services particularly are trying to understand whether they're dealing with one entity or a number of entities when they're like making loan offers or sort of seeing people not defaulting on loans, even that kind of thing. When they're doing the sort of know your customer analysis, if a new person applies for banking facilities, loans, whatever. And then the other one is around sort of customer experience and customer understanding. Sort of the big consumer companies like, the entertainment companies rather, like Netflix and Amazon and so on. It's really important to them to understand what people want from them. And people are coming in on different channels. They might use a mobile device, they might use a laptop, they might use their smart TV or something like that. And they might log in different ways. They might not need a login. It depends on the service. And people are trying to understand who are these people, what are they trying to access? Or retailers, again, they're trying to understand who wants to get things from them, to try and understand propensities and things. And so the knowledge graphs are a very good sort of basis for doing that kind of analysis, to try and tease out what if it's the same person or different people that are coming in different channels and wanting different things. So that's, I think, I'm seeing a lot of interest in that and seeing a lot of people using knowledge graphs in that context. So those are the two big areas that I'm seeing.
Yeah, fraud detection, identity, customer experience, the sort of real-time recommendation stuff are really solid use cases today for knowledge graphs. I think there are many more in analytics and data science that we're yet to see. But as the tooling and skills get more sophisticated, I would expect to see a huge growth in the use of knowledge graphs in all sorts of different spheres.
Yeah, I think to come back to the point we made earlier, people are starting to think of not just using one type of database all the time. Now they've got technologies like WANdisco and so on to sort of, easily move data between different data stores. They can start to think about, using the right data store for the right use case, the right workload. And so they can run relational, Snowflake or something alongside Kraken, alongside, Cassandra, alongside something else. And with maybe a common sort of semantic layer to hold it all together or something like that. So I think, this is the big emerging trend to me, is that people are thinking about, using different databases. It's not one size fits all anymore. We don't need to do things that way as we move into the cloud and have these newer, higher performance tools to support things.
And, I'd agree with that. Yeah, I was going to say, I'd agree with that. I think, to keep it short and sweet, I think kind of readoption of Hadoop and to a lesser extent NoSQL has really blown the doors wide open in terms of people being ready to accept databases which aren't just relational.
Yeah, I mean, so one thing that I think also comes out of everything that you guys say is that it's become much more dynamic. Data is flowing much more quickly into different systems, into different kinds of systems, databases, really, and to allow these more use case based approaches, really, and seeing what works individually, and rather than having that one data warehouse where you have to make everything fit because that's what you have. And I think a lot of the power of the latest development comes out of the ability to do all of that without having to do a 2 or 3 year project for each one. So I think that's very clear.
Yeah,
Okay.
most definitely. I mean, where the largest fixed cost is likely to be computing cloud for many companies, it's unlikely that any company will choose a single cloud and they'll arbitrage between different clouds and different applications. We're already seeing that happen right now.
Yeah, absolutely.
Exactly. So I think we should probably wrap up. So thank you guys very much for joining the panel and for your comments. And yeah, enjoy the rest of the conference then.
Okay, thank you.